Hi, welcome to Kelsey Ed, and today we're looking at the IGCSE Computer Science Paper 2, and we're going to look at the section B, which is not the pre-release but the algorithms, flowcharts, trace tables, and finding errors. This could be quite a tricky part for some people, so we're going to run through a few problems. There's some questions and answers, so please have a go answering the question yourself first, pause the video, and then see how I did it, and if you're able to improve. I've got two different flowcharts in there with a trace table, so there's a chance for you to try and improve on the second one as well. As always, if you like these videos, then please like and subscribe so that you can be the first one to know when new content arrives. So our first question is about finding errors inside of the code. And so what we have to do is just try and figure out what's the algorithm supposed to do and just work our way through and look out for any sort of indicators that make us say, oh, hold on, that doesn't look right, or that's not what I'm used to doing. So if we start at the beginning here, the total is set to 0, very normal. The counter is then set to 50. So for me, this is immediately a red flag because we usually declare our variables or initialize our variables at a low number unless we're counting like a higher or something. So it's not that it can't be or it's never going to be declared high, but to me this is my first warning sign. So I'm going to watch how the algorithm goes through, but that's unusual because it says here that this is going to be to enter 50 numbers one at a time. So that would mean my counter would have to be going backwards if it's at 50. So next we come into a loop here, and the first thing it asks the user to do is to enter a number. We input that number, and then it says that the total plus number will equal total. So there's also immediately, this one is a really easy error for you. There's no logic here at all in the error. It's a syntax error. So two types of error, logic and syntax. This is syntax. It's just completely the wrong way around. So I'm going to throw that one in without even finishing the algorithm. It's definitely incorrect. It should be that the total would be assigned the value of total plus number. So this is a syntax error, nice and easy. So next it tells me that number should equal number plus 1. And then it says until the counter is equal to 50. Immediately we can see here that the counter is ending already at 50. So this loop will only run once. So this is definitely an error like we thought at the start. So we'll put that the error is on line 2 because it's this part of the declaration, and to fix that we would simply set the counter to 0. So we're going round in this loop, and the other thing that stood out to me here is that it said number equals number plus 1. The counter, we just fixed this counter so that it would start at 0. If it was now starting at 0 and running through, this would actually now be infinitely running because we're counting on number. We're doing number equals number plus 1. And what we should be doing is looking at the counter. So these are key things to look at here. Look at the counter variables. Is the counter being added onto correctly? And in this instance, there is no counter. It's adding number equals number plus 1 instead. So line number 8 would be our next error. And we can fix that by simply swapping it from number to counter. This loop runs and everything seems to be fine. We've gone through. You can trace a full 50 values if you want, but I'm pretty sure we've got all of these and there's only one left. So let's look now. Average equals number times by counter. So, well, we know how to calculate a mean average, I think. We calculate our average with a division of the number of items, not a multiplication. So this would easily be our last error on line number 10, and it should be that the average is the total divided by the counter, and it should be the total, not the number, because the number would just be the last number that was input. It wouldn't be the running total, and the average should be the total of all the values divided by the number of values. Our next question is about top-down design. As you read through this question, you'll be able to answer it, and the key is to actually read the question and take the information. IGCSE questions that give you all the information you need in the question. Take your time to read it and pick that out. And what we're going to do is we're going to populate this structured chart. So it's a subsystem broken down, system broken down to subsystems. Let's find the missing pieces. So, a satellite navigation system works using destination details entered by the user, either a new destination or chosen from a previous saved destination. It works by the user entering details of a destination. Well, I've got input destination right here. So, immediately this is a flag to me. I'm looking for input destination. So it says either a new destination or a previously saved destination. So what are the two possible input options? Well, there's a new destination or a saved destination. Pretty simple, huh? The satellite navigation system will then output directions to the destination in the form of either a visual map or a list of directions. So actually you can see here, here's the map and here's the list, and it mentioned this was output directions. Well, we've got input destination here. This one must be output directions. Verification and validation. First of all, how about we look at a definition of these two statements, because we're going to have to define if the statements represent either of those. Verification. Let's think about when you verify that something is correct. Let's say mum says, meet me at 4 at the station. You say, hold on, can I verify that? We're meeting at 4 at the station. And you repeat it back to them. You do a little double check. You verify, is that the correct time? Maybe I might call up the restaurant and say, hi, I just wanted to verify the time that I have my reservation for. Can I verify that it's 4 o'clock today? I'm double checking the time. They're going to verify, yes, Kelsey, that is at 4 o'clock today. So verification is when we check that the data is accurate by comparison with the original source. I compared it with my mother, I compared it with my restaurant. Here you could be comparing it with a program that's copied from, a paper that it's copied from, the system it's migrated from, wherever it's come. So that's verification. What about validation? Well, validation, you want to make sure that something is valid. Like, I want to go to Disney World, I have coupons, can you check they're valid? No, sorry, they expired 3 days ago. If something is valid, then it needs to be accurate and within the correct limits. Okay, it should be accurate and within the limits. So this is an automatic check. So think about when you do your programming, you put in validation. You might have them have to enter a number that is greater than 0 but less than 100. Okay, you validate that, and the system will then automatically check any data which is input and make sure it meets that criteria. So it'll make sure it's accurate by checking that it's within the bounds of those limits, and also that it's the right data type. If it's supposed to be numeric and you put in 2 TWO, then it should reject that data, and there will be some sort of way for you to re-enter of a statement. Automatically checks the accuracy of a barcode. We've got some keywords here, automatic and accurate. Pretty sure that's going to be validation. And we know that on a barcode, when you have those bar lines, you have a check digit, all different ways of automatically checking the accuracy of a barcode. So to check if the data input is sensible, tough one. So is it going to be sensible? So actually, when we refer to accurate, you may also hear the terms reasonable or sensible. These are all validation. So you may have it so that a temperature could not be, negative 1000. So checking that it's sensible would also be a validation. Is it valid? Is it sensible? Does it make sense? So next, to check the data input matches the data that has been supplied. So when we're matching something against, we are making a comparison between. This one will be verification. And the last one, again, we've got a keyword automatically. So it checks that all the required data fields have been completed. That would again be a validation rule because it is automatically checking that data. Okay, so here we're going to talk about some loop structures, and this asks you to describe the purpose of each statement in this algorithm. It is good practice to learn the key vocabulary for your loop. So let's have a little start first of all on this for loop, which only has 3 lines, and we can describe this quite easily. So a for loop is a loop which will run for a set number of iterations. This one is specifically going to run 300 times, from 1 to 300. Okay, so on this first line, for I 1 to 300, what it does is it declares this loop structure and it creates an iterator called I, or a counter. Could call this a counter or an iterator. It declares that variable as I, that counter or iterator, and says this is going to run from 1 to 300. So it's going to run 300 times. So it will iterate 300 times. Next is nested within the loop. So we look at our indentation. This is within the loop. So this will run for the number of times within the loop. So it asks us to input and then a name. And notice these square brackets that are used here. When we see the square brackets, we should immediately be thinking about an array. So this is actually talking about an array which is called name. And whatever value is input will be assigned to the index position I within the array. So this is going to start by sending the first piece to position 1, to position 2, to position 3, to position 4, and so forth. And then this section, our last line, next I, well, that indicates that it's the end of our loop code. So anything before the next I would be included in the loop. Next I indicates the end of the loop and where it should begin iterating round. And the for loop will add to the iterating value at the end of the loop. So this I is indicating it's the end of the code contained in the loop and the point when the variable I will be increased by 1. And this will run until it's iterated 300 times. So the next part of this question asks us to identify, using pseudocode, another loop structure that the algorithm in part A could have used. So in the IGCSE, we're looking at 3 main loops. We have a for loop, which will run for a set number of iterations. We have a while loop, which will run while a condition is true, but may never run. And a repeat until loop, which will run until a condition is true and will run at least once. So we've used a for, which means we are left with a while loop and a repeat until. And I would like you to look, it asks for pseudocode. So when we're putting the pseudocode, it's no good just putting while loop. We're actually going to put in while, do, end while, repeat, until. And we just put these little ellipses in here, which basically indicates that there would be code happening between those. So while this condition is true, do this code, end while. So the dot just represents where the code would go between it. Okay, so next we're going to write an algorithm. We're going to use pseudocode, and the trick to this is to just take your time, break it down slowly, and not be concerned that it is complicated. It may be a lot easier than you think, and even if you don't think you've got the full solution, putting down even just a couple of statements that would be included can bring you some marks here, and it may also just get you to the end of the algorithm. So we're going to input numbers between 0 and 100 inclusive. Now, careful when you read this because it says to input a number. So actually it's not numbers, it's only one. So you may think you have to do a whole loop structure here. Well, I may use a loop still. But to input a number between 0 and 100, so we only need one input, and the algorithm should prompt the user for the input, output an error message if the number is outside range. So we're dealing with one variable, specifically number. So that's the first thing that I'm going to declare. And I'm going to set it to 0 initially. And then I'm going to ask my user for an input. So I'm going to output enter a number between 1 and 100, between 0 and 100. Because it's inclusive, it means that you should include 0 and include 100. Then I put the input number statement. So in pseudocode you do output and then input. You can actually get that all into one statement, but more preferred across most is this. So then I have used a while loop for my validation. This is my personal favorite validation way, and even though this is only asking for one input, if you wanted to repeatedly check until you got the correct input, a while loop is my preference. So I'm going to put in a condition. So the while loop runs while a condition is true and may never run. This loop will only actually run if this is true and somebody enters an incorrect piece of data. So the number, mine's going to run while the number is less than 0, and oh my goodness, look at that. So actually there is an error in my code right there, and you know what, we're actually just going to talk through why that's an error. What number in the world can possibly be both less than 0 and greater than 100? It's not possible. Actually, I needed to put in there an or. It needed to be either of these. If it's less than 0 or it's greater than 100, then it would output this error for me. So we switch that over to or. It's going to output an error. Number outside range, please enter a number between 0 and 100. So in error message, you should always explain what the error is and how to fix it, and I've used words instead of numbers. So this is looking for an error message, and error messages should be descriptive. The user will then have another chance to input, and that's the end of my while loop. So if there's a number entered that isn't valid, this will run and ask them to re-enter that number, and it will actually repeatedly run until that is complete. And so that's all you actually have to do for this question. It doesn't ask for any output other than this error message. It doesn't ask us to do anything with this number. So that's my solution. Now, if that is a little bit too complicated, there are a simpler approach, because it only asks you to enter one number, does not ask for any specific loop, and it only asks you to test that one number. There is an alternative that we could use here. So we declare our number as usual, we output for the user to enter, input that number. You could also just use an if statement here. So if the number was less than 0, and look at that, what is going on with the Kelsey ad today? Magically switch that one over to an or. So if the number is less than 0 or greater than 100, then output this error message, so same as above, and give an option to input the new number, and if. So because it only needs it to run once, it's perfectly okay to use an if statement here as well. So either of these two that you understand would be perfectly acceptable. All right, trace tables. So some people find these quite difficult at first, but I think once you know how to do it, it's actually quite simple. You just need to practice it a couple of times. So what you're going to do first of all is try to make sure that you understand what the flowchart is trying to do. This flowchart inputs a range of temperatures in degrees Fahrenheit. As each temperature is input, it compares it with the previous highest temperature. If it is higher than the current highest, it replaces the highest temperature and then converts it to degrees Celsius. So it's going to find whatever is the highest, and it will also convert that Fahrenheit to Celsius. For the ease of calculation, the final step Fahrenheit Celsius conversion has been approximated as division by 2. Super. When -1 is entered, the input process stops and the highest temperature in both Fahrenheit and Celsius is output. So classic exit of a loop condition here using -1. So we're going to be looping round until we get a -1 input. And so you can see this is the loop here, repeating for the temperatures to be entered. The user will input within the loop. If it's equal to -1, then we're going to exit that loop and print. Otherwise, we're going to continue to loop through. And it will also check within the loop if the temperature is higher than the current highest. So to approach a trace table, what we should do is first of all initialize the top row. So whatever are the initializing variables, throw them in at the top here. High F and high C are both initialized at -100. They are deliberately low numbers so that they will definitely be replaced by the highest number. And then we just start going through this table. So the values that will be input, so this is our test data here. It's a test data set. It's got a number of items. You're going to choose them one by one. So we take 68 and we're going to run that through. So we input the temperature 68. Is the temperature F 68? Is 68 equal to -1? Well, no, it's not. Is the high temp, so is 68 greater than high F? Yeah, pretty much it is. So high F will now be given the value of temp F. So in high F, you're going to put in 68. Then it says high C will then be given the value of temp F minus 32 divided by 2. So 68 minus 32 divided by 2 is 18. And then we loop around again. What's our next temperature? Well, the next temperature is 46. Is 46 equal to -1? No. Is temperature F greater than high F? Well, no, it's not. 46 is lower than 68. So back we go around to here. What's our next temperature? It's 50. Okay, is 50 equal to -1? No. Is temp F 50 higher than high F? Well, no, it's not. So back around we go. Next input. Our next input is 86. Is 86 equal to -1? No. Is temp F higher than the high temp? So is 86 higher than 68? Actually, yes, it is. So high F will be written into by temp F. So we're going to assign high F the value of temp F, which is 86. High C will then become temp F minus 32 divided by 2, which is 27. And we continue to loop around again. Next number, 65. Is 65 equal to -1? No. Is 65 higher than 86? No. Back around, next number, 50. Is it equal to -1? No. Is it higher than 86? No. Next number, 40. Equal to -1? 1? No. Higher than temp F? No. Next number, 30. Look how good we're getting at this. Input temp F, 30. Not equal to -1. Not higher than 86. Next number, -1. Hold on. Is temp F equal to -1? Yes, it is. That is our exit condition. So we're now going to follow this line down to the output. So the highest temperature is high F followed by Fahrenheit. So look at what is a text string. So we start here with the output with a text string. So you can see the speech marks. It says the highest temperature is comma space end of text string comma variable high F comma new text string space Fahrenheit comma space end of speech mark comma high C. So the variable high C, comma, space, Celsius. So the highest temperature is high F, 86, Fahrenheit, 27, that's the high C, Celsius. The highest temperature is 86 Fahrenheit and 27 Celsius. 5 marks, no problem. All you had to do is just read through a flowchart and populate a trace table. I've got another one of those coming up a little later in the video, so try that one out and see how you do. Okay, so now we're going to write an algorithm. This algorithm is a bit larger than the last one, but we're going to break it down and I'm going to show you 2 different ways that you could approach this question. So it asks you to input 3 different numbers and then output the largest number. You can use pseudocode or a flowchart. Some people will find either way easier, whichever one is easier, that's what you do. Do what's good for you. First of all, I'm going to declare the largest number because we're trying to output a largest. So that is set to 0, ready to be replaced by something large. And I've also declared 3 variables, number 1, number 2, and number 3. Those variables then need to have values assigned to them by the user. So I enter 3 numbers and ask for those 3 numbers to be input into my algorithm. So what I'm going to do is I'm going to do comparisons. So I'm going to systematically work through using nested ifs. This may be a bit complicated, but for me, this is the most logical. So what I've done is I say, okay, if number 1 is less than number 2, okay? So what I'm saying here is number 2 is larger than number 1. Like number 2 is our largest of these 2 numbers. So if I know that number 2 is larger than number 1, then all I need to do is find out if number 2 is larger than number 3. So I'm going to see, is number 2 less than number 3? So if number 3 is bigger than number 2, and it's also definitely going to be bigger than number 1 because number 2 is bigger than number 1, then the largest number must be number 3. But if it's not true that number 3 is bigger than number 2, and I already know that number 2 is bigger than number 1, then the largest must be number 2. First section. In my else section, I'm going to do some further tests using number 1. We know that number 1 at this stage, we said if number 1 is less than number 2, this is the else condition. So right now we know that number 1 is bigger than number 2. Okay, so number 1 is definitely bigger than number 2. So we're asking, is number 1 bigger than number 3? So if number 3 is less than number 1, then the largest must be number 1. Number 1 must be larger than number 2 and number 1. So if number 1 is not the largest here, if it is not larger than number 3, then that means that number 3 must be the largest because number 3 is definitely going to be bigger than number 2 and we've just confirmed it's bigger than number 1. End of if. End of if. Also output largest. So to me, that makes most logical comparison sense. Some people might find that quite complicated. And so I have here for you a flowchart option. So here is a flowchart example of another approach to this. The same thing, we've got our start, I do my input number 1, number 2, number 3. What I do is immediately assign the largest value to be number 1. Number 1 will just be given largest. It's the biggest until proven otherwise. Then we will do a test. So if number 2 is bigger than largest, so if number 2 is bigger than number 1, or whatever is stored in the largest, so if number 2 is bigger than the largest, yes it is, then number 2 will be written to largest. Either way, whether this one is written to largest or not, we will then retest again. It still holds the value from number 1, or it holds the new value of number 2, we're now going to test that against number 3. So if number 3 is greater than largest, same thing again. If it is, we would rewrite this into the variable, or we would go to no. But either way, we've now found the largest because we've gone through testing each number against a variable stored as largest. So both of these would be valid approaches. It's really about how you prefer. You could write something like this in a flowchart. You could write something like this in pseudocode. It's really up to you. But the important things here are to make sure if you do a flowchart, you get your symbols correct. So input, outputs, process, decision, and that you have your flow arrows and they have arrowheads on them. And for the pseudocode, the most important thing is to be matching up your end ifs. So if you have a nested if statement, they're all matching here, and this if statement is matching here, and we have capitalized. So I've made that amazing algorithm. Now we want to test our algorithm. So we need two sets of test data. Always pay attention, it says sets. When we ask for a set of data, I would advise at least 3 items in that set. And so there are 3 different types of test data. The 3 different types of test data are normal, abnormal, and extreme. This is a difficult one to have extreme for because we haven't set any upper or bottom limits to the numbers that could be entered. So I would stick to normal and abnormal for this section. So a normal test would just be any 3 numbers or 5 numbers that would definitely be accepted. So normal data is within the expected range and would produce the expected output. So the middle value number 2 is the largest, and that is what I would expect to be output as the largest in this normal test. My next set is deliberately abnormal. So what I've done is I've put 3 numbers, but I've written them as words instead of numbers. So abnormal data is outside of the range of an incorrect data type. So I have deliberately chosen an incorrect data type. It's not numeric, and so it should be rejected and cause an error. Trace table number 2. Are we ready? Are we feeling confident? Let's do this. Okay. First thing we're going to do, initialize that top row with our variables. So we've got total weight and we've got reject. They've both been set to 0. Total weight, reject, done. The flowchart inputs the weight of an item in kilograms to be loaded on a trailer. Any item over 25 kilograms is rejected. The trailer can take up to 100 kilograms. So we've got some key things to pay attention to here. Any item over 25 kilograms, oh, I can see that. Is the weight greater than 25 would be rejected. And it also says the trailer can take up to 100 kilograms. Let's have a look through that. Is the total weight greater than 100? So because it can only take up to 100 kilograms, if we get up to total weight of greater than 100, we're going to need to exit this algorithm. So you can bet if they've written it here, they're testing to see if you do it. Let's get our numbers going in. Input the weight. First weight is 13. Is that weight greater than 25? It is not, and so the total weight will become the weight plus total weight. So the 2 added together, that's 0 plus 13 is 13. Is the weight greater than 100? It is not. Back we go. Next number is 17. Is 17 greater than 25? It is not. So we're going to add 17 to 13 to make a total weight of 30. Is the weight greater than 100? It is not. Enter next number. 26. Is it greater than 25? Why, yes it is. Reject. Reject will now become reject plus 1. There will be no adding to the total weight because it was rejected. So back around we go. Next number, 25. Is 25 greater than 25? Ooh, little trick question. It is not. It is equal to 25, but it is not greater than 25. So therefore it will not be rejected and will be added to the total weight. So 30 plus 25 would make 55. Is it over 100 for the total weight? Nah. So back around we go. Next weight is 5. So is 5 greater than 25? Nope. So we're going to add 5 to 55. Our new total weight is 60. Is it greater than 100? No. Back around to here. Next weight is 10. Is 10 greater than 25? No. Add 10 to the total weight. We're up to 70. Is it greater than 100? It is not. Next input, 15. Is 15 over 25? Nope. Add it to the total weight. So we're up to 85, which is still not greater than 100. Next weight, 35. 35. Is 35 greater than 25? Bet it is. Reject will now become reject plus 1. So 1 plus 1 is 2. Back around for our next input. Our next input is 20. Is that greater than 25? It is not. Add it to the total weight. Now, my total weight has hit 105. If it's greater than 100, we now exit this loop, which we do. So we're on to our next section. And it says what it wants to do is do the total weight. So that's 105. Will now become the total weight minus weight. So what's currently in weight? Well, weight is holding the last value we put in, which was 20 from over here. So we're going to minus that value. So it's saying it's too heavy. Take that package back off. So we're going to minus and get 85. So 105 minus 20 will give us 85. We're back to what we had before. Then we come down to here and output the weight of the items. So that was the bit here in speech mark. The weight of the items, space, total weight, which was 85, comma, space, number of items, rejected, and then the variable reject, which was 2. We never had to enter number 15. So the data was there, but it never got entered because we reached over the 100 limit. And that is our second trace table. I hope you did well on that one. Let's find us some more errors in codes. They're trying to test us, yeah? So test me. What have you got? Let's see what you've got for us. So an algorithm has been written in pseudocode to input 100 numbers and print out the sum. A repeat until loop has been used. They mentioned the loop. If they mentioned the type of loop that was used, then that's the first thing that I will be looking at. And it also mentioned that they input 100 numbers. So we already know the set number of iterations that are required. Well, I know my loop conditions. I know my loops. And so there are 3 different types of loop. There is a while loop. It may never run and will run while conditions are true. There is a repeat until. It will run at least once and will run until a condition is true. And then there is a for loop, which runs for a set number of iterations. If you had a set number of iterations, like inputting 100 numbers, why would you not use a for loop? And that's going to be the test in this question. And so as we look through this and we read the code, everything seems super legit. So you may even look at it and be like, what error? The count is declared to 0, sum's declared to 0, we input a number, sum becomes the sum plus that number, and we add on to our count variable. Everything seems really good. It runs and then it prints out the sum, collects all the numbers, prints out the sum. But actually, the fact that they've said repeat until and they're not using something which is for a set number of iterations, check out this line here. It says until the count is greater than 100. Now we can't run through and test 100 items, but you could very quickly on your exam paper test this for 3 or for 5. I made a little table here. I made a little mini trace table. I set my variables to be 0 and 0 at the top because we're good at trace tables now. And I went through and I just started inputting numbers and seeing how many numbers I could get to before my condition. So my condition would be that it would run while count is greater than 5, and then that should give me 5 numbers if this works. And I ran through, so I entered the number 3, added 3 to the sum, and increased my count to 1. So I did the same thing. I did 4, it became 7, added onto the count 8. Now what you see has happened is that when I got down to my 5th number, so my 5th number was number 8, and that would get input here. So I would input number 8, it would be added, and so my sum would become 24, and we would add 1 to count, and count would become 5. However, it runs while it's greater than, in this example, 100, but for me it would run while it was greater than 5. And so if it runs again, it's going to run that whole loop and allow me to input another number, add it to the total, and then make the count 6 before it has a condition of greater than. So this is our error, right? This line here, this loop is going to run more than 100 times. My loop ran more than 5 times. This will run more than 100 times. So how can we correct that? Well, there's 2 key ways we could do it. Number 1, we could change the count to start 1 later, or we could change the until condition to be until is equal to So inclusive there and not just greater than. So once it reached 100 here, it would say, oh, actually, we've got 100 numbers now. Now, as previously mentioned, let's have a little look here. It says rewrite the correct algorithm using a more suitable loop structure. Well, what is the most suitable loop for a set number of iterations? Do we know? We know. It's the for loop. So a for loop runs for a set number of iterations. Anytime we have a set number, we're using that for loop. So we're going to rewrite this algorithm. So we start off with sum and the same, but you may notice, hold on, why have I not put count in? In this one, count was there and sum was there, and I'm only putting in sum. Well, the reason is, and actually there is an error in my code right here where I have not included an assignment arrow. So it should look like this, okay? And the reason that that is there is because we are declaring a count variable, but in actual fact, could call that also count. I've just called it I, but it should probably be called count. Let's change that too. Okay, so for count 1 to 100. So what I've done is I am declaring this within the for loop. So that's how it works. Because it works for a set number of iterations, the iterator or the counting variable is declared within the loop structure. So for count is going to run 1 to 100. Then nested in there, I've got the input the same, sum and sum plus number. No need for a count here. We don't need to add a line of manual counting because the loop structure does it for you. So all we need to do is indicate it's the end of the indented and we're doing our next count and then print the sum. And so this is a much more streamlined loop. So you notice, you see this is like 5 code lines, this is 4 lines of code. This is why we're using a for loop. It actually is doing all the iterations for us. It saves us from having to think about iterating. It's a reliable set number of iterations. So anytime you have a set number, we are using the for loop. So that is all of our questions for today. I hope that that was really helpful and that you were able to complete some algorithms, understand trace tables a little bit better. If you have any questions or something that you don't understand, I know your exams are coming up, so please just add a comment and we'll see if we've got time to answer them. And if you like today's content, of course, like and subscribe so you can know when the new videos arrive. Thank you and really good luck for all your examinations. You can do this.